Hello professors. Now I'm going to give you my final presentation about my thesis project, which is called Room and Mates. Room and Mates is an AI augmented matching system trying to match room and roommates together to promote a co-living lifestyle. Co-living is a trend right now. In terms of rental housing market, on the supply side, there are more multi-family house being built than the single-family house right now. On the demand side, more and more people trying to live in a co-living style. But why so? Because co-living is awesome. If you choose to live with other people, the rental cost will be hugely reduced. This is the data for average rental price in Boston in 2016. We can see, compared with living alone in a studio, if you're willing to live with other two roommates in a 3-bedroom apartment, the rental price will be reduced for around $1,000. And your living cost is reduced because besides sharing a space, you're also sharing all these household appliances. And because of sharing these things, the use of these different devices can be more efficient. But that's not the main driven factor why people choose to have a co-living lifestyle. The main reason why people choose to do so is about socializing. According to a survey did by IKEA, they did a survey across 147 countries, over 7,000 people. 37% people think actually co-living is about socializing. Co-living is awesome, but if only you can find a good match. Some people just feel like it's very hard for them to find a room and a roommate at the same time. Some people can only find a very bad room and roommate. So in that case, why people choose to live alone is not always because it's more convenient, because it's easier for them. Let's just go through a very popular website, Craigslist, to see how people usually do house searching and roommate searching on the website. So from Craigslist, if I say, okay, I want to find a room, so I just choose room and try to see all these rooms available to me. And then if I want to have some specific requirement, I can choose from the filters here. And for roommates, you can do the same. You choose area and you choose different criteria you want and check the detailed information to see if this matches your requirement or not. So basically, this method I will say is based on the filtering. What does it mean? It means all your search is defined by all these filter conditions. So you can choose if you want this information has image or not, is posted today or not, is this a private room or shared room with others, do they have private bathroom for you, is cats okay, dogs okay. These are the predefined requirements you can choose to refine your searching. And the idea of filtering is you can use these filters to narrow down the searching space so that you can have a smaller searching space, so you can just manually view all these listings to see if this matches your demand or not. Well, the problem of this method is filter limits the way people do searching, because filters are predefined by the people who design the website or the real estate people. So you only search based on their criteria, their categories, instead of your own preference and willing. And the other side of the searching process is if you can find some, luckily can find some room you like or roommates you like, the negotiation between people to agree on the choice is very hard. For example, most of the case, you can find some very good apartment, but you can not find people to live with you. Or another case is you can find some good roommates, but you cannot agree on a house to live in. So to tackle the first problem, actually we can try to understand users' preference and use that for the searching process. And for the second issue, we can try to match room and roommates at the same time, so that the negotiation will be finished once you find a match. And in order to solve these two problems, machine learning will be very useful. Use machine learning to do matching and recommendation is not a new idea at all. For Amazon, they have machine learning algorithm running at the back end to recommend products to you based on your previous viewed products. For Spotify, they will generate a weekly playlist for you based on your history of listened music. And Netflix has algorithm to recommend a movie to you based on something called collaborative filtering. But what can machine learn on room and people? For room, actually, we can see if we have the picture of a room through machine learning algorithm. We can know if the room has a window, how large is the window, if the room has like a painting here, chair, or the texture of the floor, or some decorative textures. All these elements can be captured by the machine learning algorithm. And in terms of people, besides we can tell the age, male, which can be done by basic filters right now. We can also try to learn from the information provided by their social media account, by their hobbies, and by their bios. But because of the limitation of time, this project is mainly done by with the first idea about room recommendation, and this can be done and explore in the future. So this is the project I done for this recommendation and matching system. It's called Room and Mates. And there are three main components for this matching system. So one is room preference detector, other one is roommate preference detector, and the third one is a recommendation generator. All these three things work together to help people find a match. And this is a quick video to see how the system works. So if I want to find a room, I need to register first with my username, age, and gender. Then I will need to finish a survey based on what kind of living preference I have. For example, my preference, roommate's gender, age, whether people can smoke or not, whether people can bring their pets or not, whether I can wear shoes indoor or not, dishwashing, house cleaning, items I want to share with my roommates, social activities, basically like frequency, you want to have people come by and have some party, and also interest, hobbies, and favorite topics to discuss with people. After finish the survey, you will be turned to a page which you can choose the room and the roommates. So you will have to choose whether you like the picture of this room or not, and in the end you can choose whether you like to live with people in this room. So these people actually has tell the system that they like to live in this room. So you can just see, okay, if this is a good match for you, but now it's not, people are not matched yet. So here's like, I still recommend room to you and also roommates to you. Also there's a very brief introduction about the house itself. Yes. So now there's a match, system finding a match, but let me try to explain the components in detail, what's going on for each part of the system. So first is the roommate preference detector. So because I didn't use machine learning methods on this part yet, all these things is based on the survey you saw before on the during the video. These survey questions are designed based on the interview I did before, and I did a bunch of interviews with people from different gender group, age group, nationality, and sexual orientation to ask them what do they like and what's their requirement on their roommates. And through that sort of interview, I have two different sets of questions. The first set is about compatibility of roommates. So these questions is asked like things about age, gender, smoke, pet, and the shoes. In order to match with people, you need to have the same answer with your roommates. Otherwise, they will not be compatible to live together. And the other set about the question is some living preference and some interest. So for dishwashing, house cleaning, maybe people don't have exactly the same options, but preference matching score is calculated based on how close your answer is. So this can be measured in the end and have a compatibility score for the people to see how compatible, how well they can get along with each other. So this is the people's part, and the next part is rooms part. So for now, room is recommended based on the picture of the room. For example, we have two pictures, bedroom pictures, and these pictures will be parsed through a neural network and do feature extraction. And the result of this will be a high dimensional matrix. And then we do cosine similarity between these two metrics, and then you will have a similarity score. So here's some example how good was the performance of these neural network feature extraction and similarity comparison. So let's say if we have these bedroom pictures and we want to find what's the most closest match for these roommates pictures, for these bedroom pictures in the library. And these are the two results from two different architecture. One is VGG19, one is VGG19 inner layer lock-free. And we can see actually the result is pretty good. For this one, it captured the opening like window here, as we can find in the original picture, and also the bed, which is like very wide, and this is the result. And also for this one, I think it also captures some opening, maybe lights here, and also the bed. This bar chart tells us about the distribution of the results. So this one score means the picture itself, and the distribution should be wide enough to distinguish different pictures. As we can see, because VGG is trained on ImageNet, so it's not perfectly working on the room, but the result is good enough to begin with for now. And this is the living room. So if you give system this picture, you can find the closest one get by the VGG19 is this one. And we can find and capture the window here also. And there is like a T-shaped sofa here, television here. So I would say the result is pretty close, but not perfect for now. And all these room images will be calculated by the cosine similarity to get a similarity score. And based on users' preference on the like room and dislike room, you will have an aggregated similarity score. Basically, the idea is need to maximize the room that user like and try to minimize the score of dislike room. So you have like a final result. And each different room, now we have bedroom, living room, kitchen, and bathroom in the system. Each of the room will be weighted and sum up to have a final score to tell the system which room or which house will be recommended next time. And finally, is the recommendation generator. So in order to achieve a match, as we can tell from this graph, you need to have all the people like the same house and all the people like each other. So when we find a person, let's see, they match with other people, but in this match, there's one people don't like this house. So the strategy is trying to replace this house with one that most likely be liked by all the three people. And if you find a group that people like each other and also the room, but they're missing some other people to live with in this system, so the strategy is trying to recommend other roommates who like this house and the most likely to be liked by these two people, and trying to finish this match graph. And also something worth to mention is for this match, there are some empty dots here. I will call it as a buffer. The idea of this is trying to increase the fairness of the system. So when you decide whether you like these people or not, the other people will not know the result unless they tell the system that they also like these people. So this is like a blind matching. Before other people agree with this match, they will never know the result of this match. Let's just make the information flow more symmetric. There will be no people power over the others in the matching. So after you find a match, the next step will be you can view the real profile of the person. So before all the people decide or agreed on a match, you can only view people's basic information like name, age and gender, hobbies, and some simple bios, but you cannot see people's real picture. The idea of this is trying to reduce the potential discrimination. So you can only view people's avatar, but after this, you can view people's real profile and their social media account. Once we find a match for you, there will be no new match coming to your from the system. So if you don't like this match, you can say, okay, I don't like it, I want to dismiss the match. And only if there's one people involved in this match don't like this match, the whole match group will be dismissed. So it's just, we always want to keep a group consensus in order to finish a match. And if all the people think this is a good match, the next step for them will be they can just discuss with each other and find a time, check the house, and try to sign the contract with the landlord. In order to test the whole platform, I did some user tests. So the idea of the user test is trying to understand the value proposition of this platform, trying to understand how good the user flow for this system, how good the UI design for now, how good the survey design for now, and how good is the recommendation for them. And since the target group for this platform is students aged from 25 to 30, this user test for now is specifically did within this group of people. So here's some feedback I got from the user test. First, they think it's a very interesting idea, and because of the way I designed the whole website, they feel like this is more like a game. The second feedback is they feel there's some critical information missing in the house and the people for them to make decisions. The third one is they think the UI design of it somehow is not good enough, because especially the part when you need to scroll down to see the people, make them feel not good. They want to have a parallel view window to see maybe half of the information is about the house only, and half of the information is about people. And the fourth one is they feel like somehow if you can see the real picture of people, you can somehow tell their personality from the view. And also the last point is some people concerned about how to initialize the platform, because all the platforms should base on a huge amount of user to use it to find you a match. If like a very good people don't use the platform, that means you don't have a very good house. It's not listing on the platform. That means you don't have good resources to match to be used. So these are the feedbacks. And there's some limitation for this system, as I recognized. Basically, this is about the robustness of the system. For example, now the house recommendation is highly depends on the quality of the photo of the rooms. If some people take a very bad photo of the room, there will be a high chance the house will be recognized as a bad house. So they will not be matched. And another part is the system cannot prevent people to cheat on the survey and their bio. So recommendation on people is also based on this information. That means people can trying to describe themselves as they want, not as what they really are. So these two parts will hurt the robustness of the system very much, and need to think about the strategy how to reduce the risk of these two issues. And in terms of next step, is to trying to test the whole system with a dynamic group of real users. So this idea is trying to see in the real situation how the match will happen and how will people think of the system itself. The second one is anomaly detection, in order to detect if there is like stranger behavior of users in the system. For example, if there's people only like house, they don't like any of the other users, there might be something wrong with this behavior. Or another side is if there is one people only like other people and don't like any house, in that case, in both cases, actually there will be no match for these people. So how to tell them, well, you need to do something else in order to find a match, or if they use the like website on the purpose of doing something wrong. So this is anomaly detection. And the third one is trying to do online learning. For now, all the weights of the room recommendation is fixed. How to trying to find an algorithm to adjust the weights dynamically based on people's selection is very interesting and important to explore for the next step. And also how to use machine learning to do feature extraction on the people. Basically, you can do language processing on people's bio, and trying to also like language processing on people's Facebook account, and trying to do this so we can also recommend people based on these features instead of just based on their question, the survey question they answered. And also how to deal with group searching. So if there was two people already commit to live with each other, and how to deal with this situation in the searching process. Last one is how to involve landlord into this matching process. Because for now, the assumption is we match people with an empty house. And how do you think of that there will be some people already living in that house and trying to match the roommates for these people and living together in that house? Could be also very interesting to think about. Okay, so that's the end of my presentation. Welcome to get feedback and questions. Thanks.